Hello and welcome. In this video, we're gonna go through a very common question type that comes in all mechanics exams, which is basically pulleys. I'm gonna go through everything related to pulleys for you. This is gonna be a one-stop video that you need to master pulleys, everything from how to solve all the ideas, how to solve different ideas, and how to also know the keywords or the the meaning and the assumptions of the words, just like light string, for example, light pulley, smooth pulley. What do this all mean? Because sometimes they ask them, like in this question, state how in your calculations you've used information that the string is inextensible. I'm going to be going through all of this, and I hope you benefit from this video. And before we start, I just want to give you literally like a small gift, because the support has been amazing and I've received so many emails. I've done the complete mechanics course. This course is literally a hidden gem. It has all the sections and all the chapters for mechanics, and it has solved past papers, and it's me doing the videos. If you take a look, it's me with the exact same whiteboard and exact same everything. However, I go through each topic thoroughly. You wouldn't even have an idea around how much thoroughly I go through this, and making sure that you know everything you need to know, as well as solving full past papers, okay, and a summary and modeling assumption PDFs. It's super helpful. If you want, you can email me on the email down below, which is abdurrahman.elminyawi@outlook.com. This email you can send me with a title named Mechanics 1 Udemy course, and I'll be sharing with you a discount code that you can use for your course. Anyways, let's start by reading the first question. The question says, two particles A and B have masses m and 0.1 kilograms respectively, where m is greater than 0.1. So it tells you that this is greater than 0.1. So when the system is released from rest, what do you expect to fall down and what do you expect to go up? I expect A to fall down since it is heavier. I'm going to teach you how to know exactly. The particles are attached to ends of a light, inextensible string. Here we have two keywords that come up a lot. Light basically tells you that tensions on both sides of the string are equal. The tension here is the same as the tension here. And inextensible tells you that the accelerations at both sides of the string are equal. So this string is accelerating down with a value, let's say, of 2 meters per second squared. That's going to be accelerating up with the same value, 2 meters per second squared. These are the meanings of light and inextensible, and we're going to be using them for every question from now on. Question says the string passes over a fixed smooth pulley. So smooth means that there is no friction in the pulley, and the particles hang vertically below it. Both particles are at a height of 0.9 meter above horizontal ground. System is released from rest, and while both particles are in motion, the tension in the string is 1.5. Particle B does not reach the pulley. So particle B is going to go up. It's telling you that it's not going to reach the pulley and hit it and cause like impact or whatever. The first question tells me to find M. Okay, usually all of these questions you started by the same step, the same first step every time, which is drawing free body diagram. So free body diagram, we draw it for each particle. So you think about it, what are the forces that are acting on particle A? It's going to be the weight force, which is completely down, and it's going to have a value of mass times g, which is the acceleration of gravity, and A will have tension that is upwards. A is going to move down, so it's going to have an acceleration down. When you draw acceleration, you draw a line with two arrows to differentiate it between an acceleration vector and a force vector. So acceleration has two arrows. Now this is particle M. Let's do the same for particle B. That's going to be the weight, which is 0.1, which is the mass times acceleration of gravity g, and we'll have the tension up, and B is going to move upwards with which acceleration? A as well. Why did I name it A, not A1 and A2? Because they're the same, since it's an inextensible string. Why did I name this T and I named this T? Same thing, because it is a light string. So second step is to write the equation of motion for both A and B. So let's write it for A first. So A, and we are resolving in the up and down direction. Whenever you're resolving forces or you're writing the equations of motion, take it as a golden rule of thumb. The positive direction is going to be the direction of acceleration. So you take a look, which way is my acceleration going for A? A is accelerating downwards, so downwards is going to be my positive direction, and any force that's pointing down is positive, any force that's up is negative. So over here, the force pointing down is mg, so it's positive, minus tension, which is up, and here the question gave me the tension value, which is 1.5. So this minus this should equal mass, which is m times acceleration. This is Newton's second law, that the sigma forces equals mass times acceleration. And since we have an acceleration here, it's not an equilibrium question. We have an imbalance of forces that causes an acceleration. It's going to equal ma. On the other hand, if we're in equilibrium, it's going to equal mass times acceleration, which is 0, because whenever we are in equilibrium, acceleration is 0. So sigma force is going to equal 0 in equilibrium. However, here we're not, so we have an acceleration, so sigma force is equal A. That is my first equation. It's clear that I have two unknowns, m and a, so if I have another equation magically, let's say from B, I will be able to solve simultaneously for both. So B, which direction should I take as positive? If you said up, then you are right, because acceleration for B is up. So it's going to be tension minus weight. So tension is 1.5 minus the weight, which is 0.1 g, should equal the mass of A, which is 0.1 times A. Okay, now what I can do here is straight away actually find the acceleration from this. I have everything except acceleration, so what I can do is I can divide both sides by 0.1, and acceleration is going to equal, evaluating this on the calculator, I'm going to get 1.5 minus 0.1 times, this is a Cambridge question, so take G as 10, and we're going to go through Edexcel as well, don't worry, they're exactly the same thing, okay, exact same ideas, so don't worry about that. So A equals 5 meter per second squared. So this is A. What I can do is I can substitute it over here to find M, so it's going to be mg minus 1.5 equals 5A, right? Sorry, 5m. Acceleration is 5, and this is m. So what I can do, I will group them together. I will move this 1.5 here. I will get the 5m over there. So it's going to be mg minus 5m equals 1.5. I can take m common. This is going to be g minus 5 equals 1.5. So at the end, m is going to equal 1.5 over g minus 5 is 10 minus 5, so 1.5 over 5. That's going to give me an answer of 0.3 kilograms. So m is 0.3 kilograms. Okay? Now, the question tells me find the speed at which A reaches the ground. Okay, whenever we speak about speeds and all of these stuff, we need to think about kinematics. And by the way, I've done a complete revision for kinematics. It's a very, very good video. Feel free to go check it. I'll leave a link in the top right hand corner. Now, in order to solve this, we need to think about A. The speed at which A reaches the ground, I will need to specify 2 points. My initial point is when A was here, when the system was first released. And the second point, I want to know when is A going to have, what's the speed of A as it reaches just before hitting the ground. So let me write what are the given things that I have in this question over here. First of all, in kinematics, you're free to choose whichever direction is positive. So you can choose down or up. It doesn't need to be the same as the acceleration like in dynamics. So what we do here, I'm going to take down as positive, okay, and I'm going to write the quantities that I have for A. I know that the system started from rest, so initial velocity is 0. I know that my acceleration for A is pointing downwards, so it's going to be positive, and I calculated it as 5, so it's positive 5 meter per second squared. I have S, right, which is a displacement. What is a displacement? I know that A is going to move a distance of 0.9 meters, and this distance is below my starting point, and I said anything pointing downwards is positive, so I'm going to take S as positive 0.9 meters, and the question asks me for the final velocity. So from here, which letter didn't I mention? I mentioned A, U, S, and V. That means that I didn't mention time, so I'm going to use the kinematics equation that does not include time, which goes like this: V squared equals U squared plus 2AS, and again, I go through this very thoroughly in both my revision video and even more thoroughly with lots and lots of practice in my course. So over here, V squared is going to equal U squared, which is 0 squared, which is 0, plus 2 times acceleration, which is 5, times S, which is 0.9. If I want V, I'm going to take square root of both sides. So V is going to equal square root of 2 times 5 times 0.9. This will give me an answer of 3 meters per second, and this is going to be the final answer for this question. Okay? Now, let's move on to the next question. Let's erase this. Okay, now this next question, let's start by reading. Question says, a block of wood A of mass 0.5 kilograms rests on a rough horizontal table. Okay, rough is a very important keyword. Rough tells me that there is friction between the wood and the table. This table is not smooth. The friction is not zero. There is some friction that I need to include in my calculations. And is attached to one end of a light inextensible string. Light tensions are equal both sides. Inextensible accelerations are equal. String passes over a small smooth pulley P fixed at the edge of the table. The other end of the string is attached to a ball B of mass 0.8 kilograms, which hangs freely below the pulley. As shown in figure 4, the coefficient of friction between A and the table is mu. It's not given as a number, it's just given as mu. The system is released from rest with the string taut. After release, B descends a distance. So after release, B is going to have an acceleration downwards. Okay, and that means that, let's call it A, and A is going to move to the right with the same acceleration. After release, B descends a distance of 0.4 in 0.5 seconds. Modeling A and B are particles, calculate the acceleration of B. So acceleration of B, I need to get it using, because here I'm given the distance that B moved and the time that B moved, and I know that the initial velocity of B is 0, I can use kinematics, okay? So I'm gonna wait on drawing the free body diagram. We can solve A first by using kinematics. So for B, I want to take going down as positive, okay? Actually, let me show you. If I'm gonna say going up as positive this time, how am I going to solve it? I always write the givens, so U, or the initial velocity of B, is 0. My distance, or S, is going to be 0.4 meters below my starting point, and I said up is positive, so if it's below, it's going to become negative 0.4 meters, and I have my time equals 0.5 seconds, and I need my acceleration. So now UAST, I didn't mention V, so I'm going to use the equation S equals UT plus half AT squared. So S, which is negative 0.4, is going to equal 0t plus half times acceleration, the thing that I want, times t squared, so times 0.5 squared. Solving for A, I'm going to divide both sides by half 0.5 squared. So A is going to equal negative 0.4 over half times 0.5 squared. So I'm going to get an acceleration value of 0.4 over 0.5 times 0.5 squared. That's going to be negative 3.2 meter per second squared. The negative here indicates what? If my initial direction I took as positive, so negative means down, so that means that the acceleration is 3.2 meter per second squared downwards, okay? I would never use up here as positive in the test, okay, just to make my life easier, because I know that the acceleration is going to be down, to just ease the calculations, but I just wanted to show you. So let's work with just knowing that the acceleration is basically 3.2 meter per second squared, and it's pointing downwards, okay? Now, let's do part B. Part B says the tension in the string, so now definitely I have to draw free body diagrams. B is the simplest free body diagram. We'll have just weight going down. It's going to be the mass times G. Since this is Edexcel, G here is going to be 9.8. Okay, so that's what we're going to use if you want to follow along and solve. Don't think about Edexcel and Cambridge a lot here because both ideas are very similar. This video works for both. I chose questions that are common for both Cambridge and Edexcel. So follow along, you can just use the G accordingly. But just as a rule, if you're doing Cambridge, use G as 10. If you're doing Edexcel, use G as 9.8. Okay, so that's the free diagram for B. For A, what I'm going to have is I'm going to have the weight going down, 0.5 G. I will have a normal force, okay, let's call it R, or a reaction force, because A is pressing on the table, this table, or this surface. So the surface, due to Newton's third law of motion, is going to press the other direction, is going to press upwards, which is represented by this reaction force. And I'm going to have tension this way. And since it's a rough plane, I'm going to have friction. Which direction friction is going to act? Friction always acts in the direction that is opposite to motion, not opposite to acceleration. Okay, always opposite to motion. How am I moving? Friction is gonna act the opposite way. So this block is gonna be pulled to the right, so friction is going to be to the left, and it's going to have a special equation. Friction is going to equal mu times R, because this is the maximum friction value that friction can have, because we're moving. Okay, whenever you're moving or about to move or about to slide, these are all keywords indicating that I will take friction as mu times R. Okay, so now to find the tension in the string, what we can do is we already have acceleration, which is 3.2 meter per second squared. What I can do is I can do equation of motion for B, taking the downside as positive. Here I don't have a choice, I have to follow the acceleration. So let's do that. So it's going to be 0.8 G minus the tension is going to equal, that's it, these are the only two forces. So the sigma forces is going to equal mass, which is 0.8, times the acceleration, which is 3.2. So now to find tension, I'm going to move it this side, bring this on this side. So it's going to be 0.8 G minus 0.8 times 3.2. And that's going to give me a tension value of 0.8 times 9.8 minus 0.8 times 3.2. That is going to give me an answer of 5.28 newtons. And that is going to be my answer for part B. Now, for part C, we can try and solve it here. Okay, let's solve it here. So for part C, okay, we need the value of mu. Okay, so mu is relating to this, so probably I will need to do the equation of motion for A. So for A, I'm going to resolve in the up and down direction first, because A has two components, okay, forces in the X direction, which is left and right, forces in the Y direction, up and down. So we need to take them separately. So I need to think, when I'm considering up and down, is there any acceleration up and down? Is this block going to move up or down, or is it on a horizontal level? It is on a horizontal level, so the acceleration up and down is 0. And this is a case where where we are in equilibrium in this direction. So in this direction, the sigma forces is going to equal ma. A is 0, so sigma forces is going to equal to 0 in the up and down direction. Okay, so when I resolve, I will have the forces, okay, are going to be balanced. So the upwards force is going to equal the downward forces, so the reaction is going to equal 0.5 G newtons, and that's it. For A now, in the left and right direction, now I'm no longer having an acceleration of 0. I actually do have an acceleration in the horizontal direction. So I'm going to resolve it as sigma forces equals mass times acceleration. I will take right side as positive, because that's the direction of my acceleration. So it's going to be tension minus friction, which is going to be mu times R. Instead of R, I'm going to put 0.5 G. That's why I always prefer, always when dealing with dynamics, always resolve in the reaction direction first, because usually you're going to get an expression or a value for reaction, which you will substitute in the other direction when you resolve. So tension minus mu r, do we have any other forces left and right? No. So this is the sigma forces, equals mass, which is 0.5, times acceleration, which we got as 3.2. Now, over here, I got the tension from the last side, which is 5.28. So I can just remove tension and put 5.28. And now I can solve for my mu. So I'm going to move this to this side, move this to that side. So it's 5.28. When I move something to the other side, it changes its sign. This becomes minus 0.5, 3.2 equals positive mu times 0.5 g. So if I want mu, I'm going to divide both sides by 0.5 g, and that is going to give me mu of, plugging the left hand side in the calculator, 5.28 minus 0.5 times 3.2 over 0.5 times 9.8. That is going to give me a mu value of 0.751. And this is the correct value for mu. Mu, there is no unit for mu, so you just leave it as this. But you need to take care of units, obviously, because you can lose marks. Now, question D is why I always stress on how to know the assumptions. It says, state in your calculations how you've used the information that the string is inextensible. You can say that acceleration on both sides of string are equal. Yes, and we showed this by saying that this acceleration is A, this acceleration is A. We used 3.2, which is the value of acceleration when we resolved for particle B, and we used the same 3.2, the same acceleration when we resolved for particle A. So this is what the question wants to see from you. Now, let's move on to the next question. So over here we have this question. This is a Cambridge question, so we use GS10. Let's read it. This was it was okay. It was a little tough. Okay, so we'll try to simplify it as much as we can. I believe that this would be, yeah. So two particles, P and Q, of masses 0.2 kilograms and 0.1 kilograms respectively, are attached to the ends of a light inextensible string. We know what this means now. The string passes over a fixed smooth pulley at B, which is attached to two inclined planes. Particle P lies on a smooth plane AB. That tells me that there is no friction in the plane AB. It's inclined at 60 degrees to the horizontal. Particle Q lies on a plane BC, which is inclined at an angle of theta to the horizontal. The string is taut. It didn't say that BC is smooth or rough, so I'll just assume that it's smooth. The string is taut and the particles can move on lines of the greatest slope of the two planes. It's given that theta is 60, so this theta is also 60 degrees. The plane BC is rough. Okay, now it said that BC is rough, so now I know that I need to include friction. Coefficient friction between Q and the plane is 0.7, so mu is equal to 0.7. The particles are released from rest. Determine whether the particles move. So what I'm going to do here is I will actually resolve each particle, okay, and see if I find an acceleration value. I'm going to solve for acceleration and see if I find acceleration. So starting, and this is good practice for you as well. So starting, I'm going to draw the free body diagrams. We start with P, and this is an inclined planes question, similar to an inclined planes question. So you can go and check my full revision on inclined planes as well. I'm going to leave a link to it on the top right hand corner. Feel free to check it. Now, this downwards force is going to be the weight, which is going to be 0.2 g. So mass times g. What else? What other forces do I have here? I have the tension acting in this direction, and I have the normal force acting here. I'm gonna call it R. That's it. I don't have anything else over here. So what I need to do is I need to resolve this 0.2 g. Why do I need to resolve? Because I'm going to take my forces directions, okay, I'm going to take them as this is going to be the x, this is going to be the y direction. So I want all my forces to be aligned with these two. Reaction is already in the y direction, tension is in the x direction, and it could be in this direction or in that direction as well. So I want all the forces to be in one of those four directions. However, the only problem is the weight, so I need to resolve it. So let me resolve it into two components instead of one. So a component in the y direction and a component in the x direction. This is 60, so this is also going to be 60 degrees. Why? Because if I extend this, that's going to be 90. So that's a 60, 30, 90 triangle. So this is 30. If this is 30 and this is perpendicular, then that is going to be 60. Okay. So resolving this, I'm going to have my I always start from my force that I want to resolve and see if I'm closing on my angle, like in this example, it's going to be cosine. So it's going to be 0.2 g cosine 60. And here, if I'm going away from my angle, starting from the force I want to resolve, it's going to be sine. So 0.2 g sine 60 over here. And I'm going to say that the acceleration is going to go in this direction, A. Why? Because this is heavier than this. They are both at the same slope. So 100% it's going to fall in this direction. Okay. Now we can do the same for particle Q. So we're just going to have the weight down, which is going to be 0.1 g. We're going to have the reaction force RQ, let's call this RQ, and this is RP. We're going to have the tension force, going to be the same, and we will have friction as well. So if Q is moving up, the friction should be down, so it's going to be in this direction. So friction, which is going to equal mu, which was 0.7 times RQ. Now I would resolve the weight force as well, because all the other forces are aligned in my directions. So I'm going to have a component this side, which is going to be 0.1 g cosine, because this is going to be theta as well, which was 60. So this is going to be cosine 60, and another component which I can draw over here, or I can draw over in this direction. I just draw it on top, it doesn't matter, which is I'm here and I want to go in this direction, so I'm going away from my 60 degrees. So this is going to be 0.1 g sine 60, and my acceleration is going to be upwards. Now I fully drew everything that I need. Now I can solve. So what I can do, actually, let me write it over here. I'll write the equations of motions over here. So let's start for P first. Okay, I'm going to resolve P in the up the slope direction. So I know that my acceleration is down, so any force down is going to be the positive force. So it's going to be 0.2 g sine 60. Now I'm resolving for P. This force is down, that's why I'm taking it as positive. Then minus the tension force, and that is going to equal the mass, which is 0.2 times the acceleration. This is the equation for P. Now I don't need to resolve P in this direction, to be honest, because there is no friction, so I will not use it. This is a pro tip, and you will get what I mean in a second. Let's do Q now, and let's resolve it first in the perpendicular to the plane direction. So we're gonna resolve in this direction. We know that sigma forces in this direction is 0, so forces in this direction will equal forces in that direction. I'll basically have RQ equals 0.1 g cos 60. Okay, that's the first thing. The second thing, I'm going to resolve a Q in this direction now, up the slope. Okay, taking up as positive because my acceleration is up. So I'm going to have the upward force here is going to be the tension. Okay, and then I'm going to subtract from it this downward force, which is 0.7 times RQ, which is 0.1 g cosine 60. That's why I started by resolving in this direction to get an expression for RQ. And then what other forces in this direction? I have the weight component, which is also down. So it's going to be minus 0.1 G sine 60. So these are going to be my equations over here. Let me write them down below and then we continue. Now, I forgot to equate this to mass times acceleration. So the mass is 0.1 times A. Let's write them down below. Now I wrote both of these equations down below, and now I'm ready to simplify and basically solve for A. If I got an A value, then it means we're moving. If I got an A value of 0, then it means we are in equilibrium and the whole thing is not moving. So let's see how we can do that. What I can do is I can just simplify this equation a little bit. Or actually what I'm going to do is from this first equation, I'm going to get an expression for t. I'm going to move t here. This I'm going to move it over there. So I'm going to have t equal 0.2 g sine 60 minus 0.2 a. And then I'm going to take this t, which is this expression, substitute it in this t over here and solve. So I'm going to have a big equation that goes like 0.2 g sine 60 minus 0.2a minus 0.7 times 0.1 is 0.07 g cos 60 minus 0.1 g sine 60 equals 0.1a. So now I want to group all the acceleration expression terms together. So I'm going to add 0.2a to both sides. So this is going to be basically, these are going to cancel, and this is going to be 0.3a, 0.3a. So now if I want to find the value of a, I'm going to divide 0.3 on both sides. So what I'm going to put in my calculator is 0.2 times g, which is going to be 10 here, sine 60 minus 0.07 times 10 cosine 60 minus 0.1 times g, which is 10 times sine 60 all over 0.3. And I'm going to get an acceleration value of around 1.72 meter per second squared. And thus this is tells me that the particles are moving, and they are moving with this acceleration. Okay. Now, question part B tells me that it is given instead that the plane BC is now smooth, so it's no longer rough. The particles are released from rest, and the subsequent motion in the tension in the string is √3 minus 1n. So I'm given the tension. It wants me to find the magnitude of the acceleration of P as it moves and the value of theta. So now theta's changed, okay, and BC is no longer rough. Whenever you have anything that is changing, it's always advisable to redraw this whole thing and redraw your free body diagram. This is what I always do. This is 60. This is particle P, and this is the pulley. This is going to be particle Q. It is a little bit more down, yeah, Q. So this is Q, this is P. Okay, I don't know what's this is theta. So what I'm gonna do is I'm going to redraw the free body diagram. Starting for P, it's having a weight of 0.2 g. It will have a tension, and it will have the normal reaction. Let's call it RP. That's it. And let's in the meantime also resolve the weight components. So this is going to be 0.2 g. This first is going to be, because this is going to be 60, 0.2 g cosine 60, and this is 0.2 g sine 60. And I'm also accelerating this direction. I'm not going to use the same acceleration, because whenever a single force changes, everything changes. So don't take anything from the previous, except like if the question mentioned. Okay. Now for Q, what we're gonna have is we're gonna have the weight straight down, which is 0.1 g. We're gonna have the tension value. We're gonna have RQ, and basically that's it. We're not gonna have tension like in we're not gonna have friction like in the previous question. So let's resolve the weight component to 0.1 g. This is theta, so this is theta cosine theta, and another component which is going to be 0.1 g sine theta. I like to draw the components in a different color for you guys to visualize that these are the components. So which ones are the original forces and which ones are the components. Now what we're given is that the tension here is equal to root 3 minus 1 Newton. Okay, and we're asked to find the magnitude of the acceleration of P and the value of theta. So let's start by the first thing, magnitude of the acceleration of P. Let's draw let's write the equation of motion for P, taking it in the direction up and down the plane, along the plane, taking down as positive. So now what we do is any force that's down is going to become positive. So like this 0.2 g sine 60. Any force that's up is going to be negative, which is this tension force, root 3 minus 1. And that is going to equal mass, which is 0.2 times the new acceleration. That is for P. I believe from here we can straight away divide 0.2 both sides, and that's going to give me an acceleration value of, let me plug this in my calculator, 0.2 times 10 sine 60 minus root 3 minus 1 over 0.2. That's going to give me an acceleration value of 5 meter per second squared. That's my acceleration, which is going to be the acceleration for Q as well, which is going to be in the upwards direction. So now let's resolve Q in the direction up and down the plane. Okay, no longer I need to resolve in this direction. I know straight away when I resolve, I'm going to have RQ equals 0.1 g cos theta, but I'm not going to need it because the play is all here, okay, and I don't have the friction which includes the R. The friction is the thing that includes the R, that's why I need to include it. However, if you feel like this is complicated for you, feel free to resolve in both directions, this one and this one. However, it's not really needed here. And let's take up as positive. So the equation of motion is going to be the tension, which is root 3 minus 1. Okay, and then minus 0.1 g sine theta equals the mass, which is 0.1 times the acceleration. It's going to be the same both sides. So I'm going to use 5 over here. And from here, I can find that I can move this to this side, this to that side. So I'm going to have root 3 minus 1 minus 0.1 times 5, which is basically, I think, 0.5 minus 0.5 equals 0.1 g sine theta. Divide 0.1 g both sides and take sine inverse of that. That's going to give me sine inverse of both sides. So that's going to give me a theta value of, just going to plug in my calculator, shift sine of root 3 minus 1 minus 0.5 over 0.1 times 10. That's going to give me a g value of, a theta value of 13.4 degrees. And that is my final answer for this question. I hope it's clear. Now let's try to solve this one as well. Let's erase. You don't need all of this. Okay, now for this next question, it is Edexcel, so we're going to use G as 9.8. Let's see how we can do this one. This one is a little bit tricky, so I want you to focus over here. What we can do is read the question. So figure 4 shows two particles, P and Q, of mass 3 kilograms and 2 kilograms respectively, connected by a light and extensible string. P is held at rest on a fixed smooth plane. No friction in this plane. That's what we like to hear. It's a simpler question. 30 degrees to the horizontal. The string passes over a small smooth pulley, A, fixed at the top of the plane. The part of the string from P to A is parallel to a line of great slope of the plane. The particle Q hangs freely below A. The system is released from rest with the string taut. So the question wants us to write equation of motion for P and Q. So as always, let's resolve both. First of all, which direction do you think the particles are going to move? This direction or that direction? This is heavier, so it's must move in this direction. No, not necessarily, because this is inclined. So what you can do here, you can see that, okay, when drawing the free body diagram for P, I'm going to have 3G, right? I'm going to have a normal reaction, let's call it RP. I'm going to have the tension, and I'm going to resolve my force. Now I'm not going to do it in green now. It's going to be just 3G. This is 30, so 3G cos 30 because I'm closing on my angle, and over here is going to be 3G sine 30. Okay, and on the other direction, Q is going to have a G or a weight value of 2G, and it's going to have a tension value. So what you need to see is that you're either going to accelerate this way or that way, right? Either this way is going to win or here downwards is going to win. So you want to see which force is going to be larger. Okay, the tension is the same both sides, so you can neglect it. 3G sine 30 is less than 2G, so it's going to accelerate in this direction. This is this force is greater than this force, so it's going to move down. And you can continue reading the question, it might give you a hint. And here on Q it says when Q reaches the ground, so this is an indication that a Q is going to move downwards, but it's very, very less likely that you will be confused because the questions mostly make sure that you know which direction the thing is going to move. So we know that this is going to accelerate downwards. That means that this is going to accelerate upwards with the same acceleration. Let's write the equation of motion for P and for Q. So let me actually let me write it over here. So for P, okay, I'm going to just use this direction over here. I'm going to take the up the slope as the positive, so I'm going to have the tension minus 3G sine 30 equals mass, which is 3 times A. And for Q, the equation of motion is going to be, I'm going to resolve in the up and down direction, taking down as positive. So it's going to be 2G minus T equals mass times acceleration. So mass is 2 times A. So that is basically my answer for the first part. What you can do is you can also resolve in these directions. However, it's not needed at all. Okay, so this is part A. Part B says, hence show that the acceleration is this. So we basically want to solve for acceleration. What I can see is I have a t here, which is positive, and I have a negative t here. So if I added these two equations together, the t's are going to cancel with each other. So adding the left hand side, actually let me rewrite it for you guys. So let me rewrite this question in as negative 3G sine 30 plus t equals 3A, and let's add them together. So 2G plus 3G sine 30, so 3 times sine 30, sine 30 is half, so 3 times half is 1.5, so 2G minus 1.5G. Negative t plus t is going to equal 0, and this is what I want because I want to eliminate t. This is called solving by elimination. This is mathematics. 2a plus 3a is basically 5a. So here I have 5a equals 0.5g. So now a is going to equal, here I'm going to use g as 9.8, so 0.5 times 9.8 over 5. That's going to give me an answer of 0.98 meter per second squared, and this is what I was required to show. Now question C says find the tension in the string. So it's very easy. I need to substitute acceleration in one of those equations. I'm going to use the one on the top. So 2g minus tension equal 2 times 0.98 now instead of acceleration. So t is going to equal, I'm going to move this to this side, this to that side, 2g minus 2 times 0.98. Evaluating this is going to give me a tension value of 2 times 9.8 minus 2 times 0.98. that's going to give me a value of around 17.6 newtons, and that is my answer to part C. Here to part D state where you have used that the information is inextensible, you would say that accelerations are equal on both sides. Now, the hard part of this question is it says that on release, Q is at a height of 0.8 meters above the ground. When Q reaches the ground, it's brought to rest immediately by the impact and does not rebound. The initial distance of P from A is such that the subsequent motion of P does not reach A. That means that as Q falls down, P is gonna be dragged up. When Q hits the ground, P is moving with some inertia. So when Q hits the ground, P is not just gonna magically stop. Okay, it's just gonna continue moving a little bit to the top. However, it says that in the subsequent motion, it's not gonna reach the pulley. This is what the question is telling you. The question here tells you find the speed of Q as it reaches the ground. So speed, we're talking about kinematics. So let's write the things that we have for Q. Let's take down as positive over here. So I know that the initial velocity is 0. We're starting from rest. I know that the displacement is going to be positive 0.8 because it's below my starting point and down is positive. What else do I have? I have acceleration, which is also positive because it's pointing down. It was, how much was actually 0.98, and meter per second squared, meter per second, this is meter, and I want the speed, the final speed. So now USAV, I did not mention T, so I'm going to use V squared equals U squared plus 2AS. V squared equals 0 squared plus 2 times A, 0.98, S 0.8, and square root both sides. V is going to equal square root of 2 times 0.98 times 0.8. That is around 1.25 meter per second. That is the answer for part E. Now, part F, we need to really think about it. It says the time between the instant when Q reaches the ground and the instant when the string becomes taut again. Okay, that's a heavy question. Okay, we need to understand what happens. Q is gonna move down. As it's moving down, the string is gonna stay taut. Okay, until one point, until when Q hits the ground. When Q hits the ground, the string is no longer going to be taut. It's going to be slack. Okay, so how much did Q move until it reaches the ground? 0.8 meters. Since the string is inextensible, P is also going to move up 0.8 meters. Okay, so P is going to be over here. Yeah, that's the point where where the string is going to no longer be taut, not taut. Okay, now what's gonna happen? As we said, P is not gonna magically move. Okay, if you're pulling a ball by a rope, okay, and then you remove you stop pulling, okay, the ball is still gonna go towards you because you didn't it's not gonna magically stop because it has some inertia. That's what's gonna happen to P. P is being dragged, and then the dragging force, which is the tension, is going to be cut when Q hits the ground because the string is not going to be taut. When the string is taut, there is tension. When it's no longer taut, there will not be tension. So there will not be a force that's pulling P upwards. Okay. However, P is going to continue to move a little bit over here because of its inertia, and then stop, and then it's going to start to roll back again into this direction. So when it starts rolling back again, okay, it's gonna keep on rolling, and until now the string is still not taut until it reaches this point again, which is going to have the string as taut because this is the original point where the string was not taut. So when it comes back, the string is gonna stretch again. So basically, we want to find the time between when P reaches this point, goes up, comes down back to this point again. So to do that, we will need to use kinematics. We will need to know, okay, what is the speed that P was moving over here, okay? And then I will need to know what is the acceleration of P after the tension is broken, okay? And then I can solve for the time. So first of all, we need the velocity, okay? Let's erase a little bit. So we need the velocity of P at this point over here. So the velocity of P is going to be the same as the velocity of Q. So I think we already got it. V equals 1.25. That was the velocity of Q when it reached the ground, okay, after 0.8 meters, and it's going to be the same velocity of P. So P is going to be moving in this direction with a velocity of 1.25 meters per second. Why are they moving at the same velocity? Again, because it's an inextensible string. Now, after this, I need to calculate the acceleration of a P, because now when you think about it, P is moving up. However, now the tension is no longer there, so the force has changed, so the acceleration changed. So what we're gonna have at this point over here, we're gonna have the weight force down. We can erase this. The weight force down, okay, and we are going to have, this is the weight force down, we are going to have the normal reaction force, RP, okay, and we're just gonna have the components of weight. Do we have any other force acting? No, we're just gonna have the weight. The weight is how much? 3g. This is gonna be 3g cosine 30. This is gonna be 3g sine 30. So in this direction, the only force that we have in this direction is the 3g sine 30. That means that the sigma forces is in this direction. That means that the acceleration is also in this direction. But sir, the ball is moving upwards. Yes, its velocity is upwards. However, this acceleration is in the other side. That's why it's gonna keep on decreasing until it stops. Okay, so this acceleration is the acceleration that I will need to calculate. So now what I can do is I can write the equation of motion for P now. I can say that in this direction, okay, the direction up and down the slope, taking this direction as positive because this is the direction of acceleration. So it's going to be 3g sine 30, and that's going to be the only force. So I'm just going to equate it to mass times acceleration. So acceleration, I can divide 3 by 3. So acceleration is going to equal g sine 30, or basically half of g, because sine 30 is half. This is my acceleration. Now I can do kinematics for P to calculate how much time will it take to go back and come up to this point again, so the string is stopped. Because the question asks me the amount of time between the instant when Q reaches the ground after it moved 0.8 meters and the instant when the string becomes taut again. So let's use kinematics. What I'm going to do is I'm going to say that I'm going to take let's say this direction is positive. Okay, so up the slope is positive. So what do I have for P? My initial velocity is going to be the 1.25, and it's going to be positive because it's in my positive direction as shown over here. So U is 1.25 meter per second. Okay, now my acceleration is in the other direction, so it's going to be negative, and we calculated it as negative half of g meter per second squared. This displacement, okay, I want the displacement, okay, basically I want it to come back to this position, right? So I want to find when the displacement is 0, right? So I want to find the times when the displacement is 0. Obviously, one of the solutions is going to be at time t equals 0 in the beginning when it was just moving up. That's, yeah, I have a displacement of 0. But this is going to go up and come back down again to this point, which is going to have it's going to give me another value of time, and that is going to be my answer. So I want t, right? So UAST, I did not mention v, so I'm going to use the equation S equals UT plus half AT squared. So S, which is 0, equals U, which is positive 1.25 times t, plus half times acceleration, which is negative half g, and then multiply t squared. So over here, I can see that this is a quadratic. What I can do is I can take a t out, and this is going to be left with 1.25. And then this half times negative half is negative 1 over 4g. And taking a t out of this is going to leave me with only 1t, and this is equal to 0. Solving this, I have two solutions. When t equals 0, and that was expected. And the other solution was when 1.25 minus 1 over 4g t equals 0. So now I can solve moving this to the other side. 1.25 equals 1 over 4g t. So divide by 1 over 4g, divide by 1 over 4g. T is going to equal, I'm going to put in my calculator, a big fraction, 1.25 over 1 over 4 times 9.8. That is going to give me a t value of 0.51 seconds, and this is going to be my final answer. When you're proficient in kinematics, you're gonna always have the shortest way to solve, because some people would say, okay, I'm going to find how much time did it take for P to reach this, because I know that at this point when it stopped and starts to go down, V is gonna equal 0, and then you're gonna get the displacement it went through, and then you're gonna say, okay, I want the same displacement back down again too. This is all unnecessary steps. When you know what you're doing with kinematics, you're gonna always go for the easiest approach, which is always advisable. So now we have one more question, which is also a nice question over here. It's an 8 marker. Okay, so let's see how we can do it. Question says we have two particles, A and B, masses 2 kilograms and 3 kilograms respectively, are connected by a light inextensible string. B is on a smooth fixed plane, so no friction, and angle 18 degrees to the horizontal. String passes over a fixed smooth pulley at the top of the plane. Particle A hangs vertically below the pulley and 0.45 meters above the ground. System is released from rest when A reaches the ground, so this is an indication that A is going to have an acceleration downwards, and B is going to have an acceleration up the slope. When A reaches the ground, the string breaks. String breaks means that there will no longer be tension in the string. Find the total distance traveled by B before it comes to instantaneous rest. You may assume that B does not reach the pulley. Again, what's going to happen? A is going to move this bit, which is 0.45, and as well B is going to move the same distance, 0.45 meters. At this point, B is going to be here. A reached the ground, so A stopped moving and the string breaks. There is no longer a tension pulling P. However, again, B has inertia, so it's going to continue moving a little bit to the top until it stops. And the question wants us to find all of this distance over here. So we've already solved half of the question by knowing that this part is 0.45. I need to know the distance from where B started moving without a tension force, okay, until it reached to a stop. So to do this, I need to find the acceleration of B over here, and I need to find what speed is B moving. B is going to keep on gaining speed until it reaches here. So that speed is going to be my initial speed for the next part. So let's do that. So to do all of that, we need to first find the initial acceleration, which was before anything before A reaches the ground. So what we do is we resolve again. So let's start by resolving B. This is going to be 3G. We'll have a tension force. We'll have a reaction force, RB. Now let's resolve this weight into two components. This is going to be 18 degrees. So this is 3G cosine 18 because I'm starting from my 3G closing on my angle. Here I'm starting on my 3G going away from my angle, so it's going to be 3G sine 18 degrees. Now I finished B. Now we can go to the easy part, which is A. Weight downwards, 2G, tension is up, and acceleration is down. That's it. So let's write the equation of motion for A, resolving in the up and down direction, taking down as positive because my acceleration is downwards. So it's going to be 2G minus tension equals mass, which is 2 times acceleration, which is A. Now let's do the same for B, resolving up and down the slope, taking up as positive because that's the acceleration direction. Is going to be tension minus 3G sine 18 equals mass 3 times A. So now again, if I add these two together, okay, I can cancel out the t's. So adding this is going to be 2G minus 3G sine 18, okay, and the minus t plus t is going to cancel, equals 2 plus 3 is 5A. So to get A, divide both sides by 5. You put this in your calculator. 2 times this is Cambridge, so G is 10 minus 3 times 10 sine 18 over 5. That's going to give me an acceleration value of 2.14 meter per second squared. Okay, now I found the acceleration. I can use this to help me find, after B moves 0.45 meters, how much is its speed going to be? That's what I need to know. So I know that initially, from the start, B has an initial velocity of 0. Okay, let's take up the slope as positive, and we're doing for B. So initial velocity is going to be 0. I can actually remove all of this. I don't need it. So you guys can see the diagram as well. So for B, we're using kinematics, taking up as positive. So what we have U equals 0. We have displacement equals 0.45 meters, and it's in our positive direction. We have acceleration, which is 2.14 meter per second squared. It's also in our positive direction. And we want V. So U, S, A, V. I did not mention T, so I'm going to use V squared equals U squared plus 2AS. So V squared equals 0 squared plus 2 times A, which is 2.14 times S, 0.45. Square rooting both sides to solve for V, that's going to give me a V answer of square root 2 times 2.14 times 0.45. That is going to be a 1.38. I'm going to take it as 3 decimal places. This is not a final answer, so I just need it to be more accurate. That's why. So that is going to be the V over here. Now I reach this point. What happened after this point? The string breaks. So B is moving like this. Now B, I need to draw a new free body diagram because one of the forces is no longer there, which is the tension. So B is going to have the weights 3G, going to have the reaction force RB, and that's it. I'll just have this as 18 degrees. I'll have the components of the weight 3G cosine 18. This is also 18 degrees, and 3G sine 18. Now in this direction, okay, I just have one force and it's in this direction. So the sigma forces is always also going to be in this direction. So my acceleration is going to be downwards, and that makes sense because I am slowing down. So what I'm going to have is I'm going to have sigma F equals MA. So sigma F, so 3 taking down as positive, we're resolving in this direction. So 3G sine 18, that's the only force there. So I'm just going to equate it to M times A. So M is 3 times A. So acceleration is going to be G sine 18. So acceleration is equal to G sine 18 meter per second squared, and is acting in this direction. Now I can find the distance it will take for B to move until it reaches to a velocity or instantaneous stop, which means a velocity of 0. So again, kinematics. Let me this time take also up the slope as positive. So my U is going to be my previous velocity, which is 1.388, and it's going to be positive 1.388, because that's the velocity that B is moving with at this instant. My final velocity, I want to see when the particle stops, so when V equals 0. Acceleration is going to act in the negative direction and down the slope, and it has a value of G sine 18, so I'm going to take it as negative G sine 18 meter per second squared, and I want my displacement. So UVAS, I did not mention time, so I'm going to use V squared, which is 0 squared, equals U squared, which is 1.388 squared, plus 2 times acceleration, which is negative G sine 18, times S, moving this to this side, or actually moving all of this to that side to have everything as positive. I'm going to have 2G sine 18 times S equals 1.388 squared. To find S, I'm going to divide both by 2G sine 18, divide 2G sine 18. That's going to give me an S value of 1.388 squared over 2 times 10 times sine 18. That is going to be 0.312 meters. So that is this green distance over here. So the question asks for the total distance traveled by B before going from stop to the end. So it's going to be the initial 0.45 plus the final 0.312 that I calculated. So S total is going to equal 0.45 plus 0.312. And this is going to give me an answer of 0.762 meters, and this is my final answer for this question. I really hope that this video was helpful for you. Please guys, leave a like, support this as much as you can, share it. It's very useful, it helps me keeps going. And don't forget to check the links and send me an email for the discount for the course. If you have any questions or inquiries, leave them in the comment section down below. Thank you so much for watching and have a nice day.